Welcome to WSHS Algebra 1 Virtual Tutor. Today's topic is simplifying radicals. So the first thing you have to look at is your parts to a radical, and you have to be able to break this down. Our first things first is this n. So this little number that you sometimes see inside the little check mark of the radical sign here is what we call the index. The whole thing is what we call a radical sign. And what is inside of the radical is what we call the radicand. And then this whole thing, the index, the radical sign, and the radicand all make up what we call a radical. Radicals can also be called as square roots, but if the index changes, it changes with what the index is. So if the index is 3, it's then called a cubed root. So what's helpful to know is what numbers are perfect squares. So how do we get this? 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 64, 81, 100, 121, and 144. So this is a number times itself are perfect squares. Now, when we take the square root of these numbers, or the radical of all of these numbers, you end up getting what their perfect square is. So the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. And the square root of 144 is 12. Now there's more of these, 13 times 13, 14 times 14, and so on and so forth. So considering your solutions above, what are the square roots of the following? So we can just look at this. Square root of 4 is 2. Square root of 36 is 6. Square root of 49 is 7. Square root of 100 is 10. And square root of 144 is 12. So in order to simplify a square root, we must be able to know what prime numbers are. So prime numbers are 1 times itself are the only factors of those particular numbers. So we're starting off with 2. I can't think of any other number besides 1 and 2 that multiplies together to give me 2. Other prime numbers you see a lot of: 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and so on and so forth. So there's more prime numbers than what we just listed, but these are the common ones that you often see. So in order to simplify a radical, you can see that there's steps here. The first thing you want to do is you want to check to see if it is a perfect square in your calculator. So in order to see if something's a perfect square in your calculator, how we do this is we press second x squared, and then from there you are going to plug the number in. So we're looking specifically at the square root of 24. So I'm going to plug in 2, 4, and press enter. This gives me a decimal. If it gives you a decimal, it is not a perfect square. So it is not a perfect square, so then I have to go on to the next step. It says, if not a whole number, find 2 numbers that multiply to give you that radicand. So let's think. 24. 2 numbers that multiply together to give me 24 are, let's do 3 times 8. Is 3 or 8 either one of those numbers in my prime numbers? Yeah, 3 is. So when I find a prime number, I'm going to circle it. That means that I cannot break down this number any further. Now we're going to break down 8. 8 breaks down to 2 and 4. Out of 2 and 4, 2 is my prime number, so I'm going to circle it. And then we have 4. 4 breaks down to 2 and 2. Both are prime numbers. Now that I have all of my prime numbers, I am going to put all the primes in the radical sign. So I make my radical and put all my prime numbers in, and I like to go from least to greatest. So 2, 2, 2, and a 3. Notice I put little dots in between. That's representing that there's multiplication going on in between it all. The way this works is these prime numbers, if you multiply these prime numbers together, 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. Next thing you want to do is you want to circle twins. So you need to have pairs in order to come out of the radical sign. So I have one set of twins, and when you circle them, they get to come out of the radical sign. And when they come out as one number, which would be 2. I look what else is left over, and I only have a 2 and a 3. Those aren't a pair. They don't match. They're not twins. So that means that they're left inside the radical, and it'll be 2 times 3. If you had other numbers on the outside, you would multiply them together. We don't. We only have a 2, so we're just going to carry that down. 2, square root, and then whatever's left over on the inside you want to multiply together. So 2 times 3 then gives me 6. So your final answer is 2 square root 6. For letter B, we have the square root of 96. All right. Well, you always first want to check out to see if it is a perfect square in your calculator. It is not. So that means I have to break it down into its primes. 96 breaks down to 2 and 48. Circle the 2. 48 breaks down to 2 and 24. 2 is prime. Circle it. 24 breaks down to 3 and 8. 3 is prime. 8 breaks down to 2 and 4. 2 is prime. 4 breaks down to 2 and 2. So now I'm going to take my square root sign, and I'm going to put in all my prime numbers. I have 1, 2, 3, 4, 5 2s. So 1, 2, 3, 4, 5, and 1, 3. Again, you're looking for pairs or twins. I have one set, so they come out as a 2. I have another set, so they come out as a 2. And I don't have any more. I just have a 2 and a 3 left over on the inside. 2 times 2 is 4, square root. 2 times 3 is 6. So your final answer is 4 square root 6. Notice with letter C, it's 5 square root 252. So when you break down 252, when you take out twins, biggest thing is you have to remember there's a 5 out in front. So we're first going to break down 252 into its primes. 252 is 2 times 126. 126 breaks down to 2 and 63. 63 breaks down to 3 and 21, and 21 breaks down to 3 and 7. Circling my prime numbers as I go along here. I am now going to put these back into my square root. But remember, I'm putting this 5 that we have out in front. And we have a 2, a 2, a 3, and a 7. Again, you want to look for twins. So we have a set of 2. They come out. A set of 3. They come out. And that's all I have left over, and just a 7 inside my square root. Now you can't forget to bring down the 5 that's in front as well. Now we multiply 5 times 2 gives us 10. 10 times 3 is 30. So your final answer is 30 square root 7. Again, a lot of people forget about this 5 here. You cannot forget about it when you multiply by your numbers on the outside. All right, let's complete the you try. You want to break down 54. 54 breaks down to 9 and 6. 6 breaks down to 2 and 3, both are prime. 9 breaks down to 3 and 3, both are prime. We have this 4 out in front, so we write 4 square root. And we put in all prime numbers. 2 times 3 times 3 times 3. And we want to find twins. I only have one set of twins, and there are 3. But remember to carry down the 4 as well. So we have 4 times 3, square root, and what's left over is a 2 and a 3. So we have 4 times 3, which is 12 on the outside, square root 2 times 3, which is 6. So your final answer is 12 square root 6. Now, that's square roots. That's when the index is 2. Now, we're going to do the same thing, but now we're going to look at cubed roots. So it's the same as a square root, but instead of taking out twins, you take out triplets. And this little 3 tells you to take out triplets in the index. So there is a calculator trick. It is right here, so please make sure you note of this. If you ever want to check to see if something is a perfect cube, you press Math, number 4. It gives you the cubed root sign. You plug in what number you need in your radicand and hit Enter. It will then tell you if that's a perfect cube or not. Now, when we look at letter A, the steps, they check to see if it's a perfect cubed. It is not a perfect cube, so that means I have to make my factor tree. So I'm going to break down 54. 9 times 6, 3 times 3, 2 times 3. I'm still circling my primes, and I'm still putting them back inside my cubed root this time. So we have 2 times 3 times 3 times 3. Now, the difference is in order to get outside of the cubed root, or your radical sign here, you have to have a set of triplets. So we have a set of 3, and then you ask yourself, what number's inside my set of 3? And you just simply say, oh, 3. And we're left with a cubed root, and there's only a 2 left over. So the cubed root of 54 is 3 cubed root 2. Notice that that's different from what the square root of 54 is. Letter B, we have 5 cube root 320. We're going to break down 320. 320 breaks down to 10 and 32. Neither are prime. 10 breaks down to 2 and 5. 2 and 5 are both prime, so I'm going to circle them. 32 breaks down to 4 and 8. 4 breaks down to 2 and 2. 8 breaks down to 2 and 4. And then 2 and 2. Again, we're making our number out in front, 5, cubed root, and we're going to take all of our primes. I have 1, 2, 3, 4, 5, 6 2s, and 1 5. Now we're looking for triplets here, so we have one set of 3. They come out as a 2. I have a second set of 3. They also come out as a 2. And then last but not least, I have a set of 5, my 5 out in front. Cubed root, what's left over? My 5 is left over inside the cubed root. It does not get to leave the radical sign. Now I multiply my numbers in front. 5 times 2 is 10. 10 times 2 is 20. So your final answer is 20 cubed root 5. Letter C is negative cubed root 162. So same idea, you want to break this down. 162 breaks down to 2 and 81. 2 is prime. 81 breaks down to 9 and 9. 3 and 3. 3 and 3. So when we go and plug this in, it's negative 2 cubed root 2 times 3 times 3 times 3 times 3. And again, we're looking for triplets here because it's the cubed root. The index tells me that it's the cubed root. And I have one set of 3, so they get to come outside of the radical. -2 gets to come down as well because it's also outside of the radical. Cubed root. And we have a 2 and a 3 left over. Now we're going to multiply everything together. What's on the outside multiply and what's on the inside you multiply. -2 times 3 is -6. Cubed root, 2 times 3 is 6. So your final answer is -6 cubed root 6. Now, for your U-try, we want to break down 3024. This breaks down to 2 times 1,512. 1,512 breaks down to 2 and 756. 756 breaks down to 2 times 378. 378 breaks down to 2 times 189. 189 breaks down to 3 and 63. 63 breaks down to 3 and 21, and 21 breaks down to 3 and 7. So that's a lot of prime numbers we got going on here, but that's all right. So we're going to take all these prime numbers and put them inside my cube root sign. So we have 2 cubed root. We have 1, 2, 3, 4 2's. Right? 1, 2, 3, 4, and 1, 2, 3 3's, and 1 7. Now when I'm doing this, I'm looking for triplets because it's the cubed root. So I find one set of twins, triplets, comes out as a 2. The 2 has no one else to go with, but I do have a set of 3, so they get to come out as a 3. And don't forget to carry down the 2 that's in front. So we have 2 times 2 times 3, cubed root. 2 times 7 is left over. 2 times 2 is 4. 4 times 3 is 12. Cubed root. 2 times 7 is 14. Not 17, 14. So your final answer is 12 cubed root 14. So when we look at numbers 1 through 4, numbers 1 and 2 are square roots, and numbers 3 and 4 are cubed roots. How do I know this? 3 and 4 have that little 3 in the index spot to show us that they're cubed root. So we take out twins, and then down here for 3 and 4 we take out triplets, and 4 is also triplets. So it's good just to jot that down so you remember. You want to break down 63. 63 breaks down to 7 times 9. 9 breaks down to 3 and 3. Take your prime numbers, put them inside your square root. 3 times 7. Circle twins, you get 3 square root 7. That's your final answer. 98. 98 breaks down to 2 and 49. 49 is 7 and 7. So we have that 2 out in front, square root, 2 times 7 times 7. You want to find your twins, so your twins are 7, so they get to come out. Don't forget to multiply by the 2 in front. Square root, what's left over? Left over we have this 2, so that's going to stay inside the square root. And now you multiply 2 times 7 to give us 14 square root 2, and that is your final answer. Now, number 3, we're at the cubed root of 500. So, the cubed root of 500, we have 50 times 10 breaks down 500. 10 breaks down to 2 and 5. 50 is 2 and 25. 25 is 5 and 5. So now I'm going to put this all inside my cube root sign. All of my prime numbers. I have 1, 2 2s, and 3 5s. Remember, this index of 3 is telling me that I look for triplets. So I have one set of triplets and there are 5. So they get to come out, cubed root. And I have 2 2s left over. 2 times 2 is 4. So we have 5 cubed root 4. Number 4 is 375. Again, this is the cubed root. 375 breaks down to 5 and 75. 75 breaks down to 3 and 25. 25 breaks down to 5 and 5. So we have 7 on the outside, cubed root, 3 times 5 times 5 times 5. Again, you're looking for triplets because the index is 3. So we find one set of triplets, and that's a 5, so they get to come out and carry down the number in front, which is 7. Again, you're multiplying 7 times 5, and what's left over is a 3. 7 times 5 is 35. Cubed root, 3. And that's your final answer. That concludes the lesson on simplifying radicals and cubed roots. Please take the time to complete the practice problems.